All right, quiz 6, math 243. We have a random sample of 900 math teachers, and of them, 800 are found to be right-handed. Create a 95% confidence interval by following the steps below. Okay, first, shape center spread. For the shape here, it's approximately normal. And the reason it's approximately normal is because n times p hat times 1 minus p hat is greater than or equal to 10. You can calculate this if you want, but n is 900. 900 times, it's going to be way greater than or equal to 10. It's approximately normal because of that. And then I'm even going to write parenthetically that it's a z distribution because we're talking about proportions. Center. Center is given by p hat. And p hat is x over n. It's this 800 divided by 900. In other words, 8/9. In other words, 0.72 repeating, I think. 0.7273. I probably check that. Pretty sure that's right. 8/9. Nope, I was wrong. Glad I checked it. This is 0.888 repeating. So maybe I'll call it 0.889. Sure. The spread, sigma sub p hat, is the square root of p hat times 1 minus p hat over n. So in this case, it's the square root of this 0.889 times 1 minus that value divided by n, which is 900. Shape center spread. All right, now I can create a confidence interval. Create a 95% confidence interval. Sure. Shoot. Let me try that again. Still not great, but good enough. Here's my approximately normal distribution. I want 95% confidence interval. Note the shade is approximately normal. The center is at 0.889. And I got to figure out this value and this value. My calculator has a function that does that for me. It's under tests. It's 1 prop z interval. 1 proportion z interval. Hit enter. It'll just ask you for x, which as we saw above was 800, and n, which as we saw above was 900, and our confidence level, which is 95%. If you hit calculate, it'll spit out your answer that our confidence interval goes from 0.868 all the way up to 0.909. Double check that I rounded those correctly. I think I did. And it shows p hat again. Great. Create a 95% confidence interval. There it is. Write a 1-sentence summary. Write a 1-sentence summarizing. Doesn't make sense. Write 1 sentence summarizing what your confidence interval from part B tells you. Sure. I am 95% sure that the proportion of all, what are we talking about here? Of all math teachers that are right-handed. Okay, I'm 95% sure that the proportion of all math teachers, not just the 900 I looked at, but all of them in the population, at the portion of all math teachers that are right-handed is between 86.8% and 90.9%. So I don't know what percentage of all math teachers are right-handed. 89% were in my sample, or 88.9%. And using that sample, I'm 95% sure that the value for the population proportion is between 86.8% and 90.9%. Anyways, good enough. Next one. Okay, question 2 on this quiz. This is our hypothesis testing question. One thing I want to change, I want to make this a 7. So on your test, this will say 7 here. So if you go through and read it, I claim to have a drug that makes people jump higher. Okay. I know that the average person has a vertical leap of 20 inches. Sounds like a population average. You'd think mu, but it's not mu. It's actually mu naught. We want mu for something else. But in a random sample of 100 people, sounds like n, that were taking my drug, the average was 22. The sample average, x bar, is 22. With a standard deviation of 7 inches. Test the claim that my drug increases vertical leaps with 95% confidence. That is alpha equals 0.05. By following the steps below. Okay, the null and alternative hypothesis. We can denote those H0 and H1. They both always are going to compare mu and mu naught. Mu naught is 20. The null hypothesis is always going to be that mu equals mu naught. The alternative hypothesis, we'll have to read the question. In here it says that the drug increases vertical leaps. So we're saying that mu is greater than mu naught. In other words, we have a right tail test. All right, describe the shape, the center, spread, stuff we always do. Okay. The shape of this distribution, it's approximately normal. Better be, otherwise we can't deal with it in this class. How do I know it's approximately normal? This is our central limit theorem. It's because n is greater than or equal to 30. If you go into the problem, our value of n was 100. 100 is greater than or equal to 30. By the way, this is a t distribution. The reason it's a t distribution is because sigma is unknown. All right, center. The center is given by mu naught, which was 20. The spread is s divided by the square root of n. S in this case was 7 inches. That's the one I changed. N was 100. 100 people. So that's 7 over 10. That's 0.7. All right, sketch some pictures. You only have to do one or the other. I'm going to do both. Let's do the p-value picture. I imagine that's the one most people will do. It's a little bit easier. Then we'll do the classical picture over here. For the p-value picture, we're going to sketch this distribution. Its shape is approximately normal. Actually, we're going to do that for both of them. Let's see, the center is 20. That's true for both of these guys. But with hypothesis testing, you don't necessarily want to know that number. You want to know its test statistic. You want to convert all of these into z-scores or t-scores. So 20 is the same as 0 because it's in the middle. Okay, so for the p-value, what we have to do is take this x bar, 22, put that over here, and figure out what this area is. Our test statistic will go down here, and this area is what's called the p-value. And what's nice is your calculator gives you exactly that. If you go down to t-tests, and you tell it you have statistics, that mu naught is 20, x bar is 22, standard deviation is 7, and n is 100, and our alternative hypothesis was that mu is greater than mu naught, then you can either do calculate or draw, whichever one you want. I'll do draw because it'll actually show me this picture right here. It goes kind of slow, but it's sketching this approximately normal distribution. And then it will tell me t equals something. That's my test statistic that will go down here. In this case, t equals 2.86. And then it'll tell me my p-value, 0.0026. Very small p-value. Should I finish this? Sure. So if I were to draw my conclusion, I would say because my p-value, which was 0.0026, is less than alpha. Alpha was 0.05, I believe. Yeah, alpha was 0.05. because my p-value is less than alpha, there is sufficient evidence to reject the null hypothesis and conclude that my drug increases vertical leaps. Something like that. Now let me go back and draw the picture for the classical method. Under the classical method, you don't look at the p-value. This was done when people weren't using calculators like this, where the p-value just came straight out. So what you have to do on the classical method is you set up what's called the rejection region. So to set up your rejection region, you go over here and you say my rejection region will always have an area equal to alpha. So this is 0.05 because that's my alpha. I want to figure out what the critical value is, what score you would need to get worse than to fall within this rejection region. And the way you can do that is you have to look at t-tables. We only want to look at t-tables. We want 0.05 to be the area, and our n was equal to 100, which means our degrees of freedom are equal to 99. So really we'd want a 99 row here. So we'd want to go to this 0.05 down to 99. There is no 99. 100 is pretty close to 99. 100 says 1.6, where is it? This one, 1.660. So what that tells me is that this critical value right here is 1.660. So what I have to do is look at my test statistic. My calculator gave me the test statistics to be 2.86 and figure out if that falls in the rejection region or not. It does in this case. It's greater than 1.66. 1.66 is right here. 2.86 is way out here somewhere. So my 22-inch vertical leap had a test statistic of 2.86, which is within the rejection region. So my conclusion would be, because my test statistic, which was 2.86, falls within the rejection region, and then the same conclusion here. So kind of either this or this, there is sufficient evidence to reject my null hypothesis and conclude that my drug increases vertical leaps. Whew, finally, that's the end of this quiz.